In this video, we're going to work with multiple representations of a given situation, identify independent dependent variables, write a function rule from a given situation, and use function rules to analyze a given situation. So here we are provided two function rules in order to solve and find values. So in number one, we have f of 4. So 4 is going to go into our f equation for x. Everything else stays the same. So when we rewrite this, we have negative parenthesis 4 squared plus 10. Well, 4 squared is 16, but that negative is there, so it's going to be negative 16 plus 10, which gets us negative 6. In number 2, we have g of 0, so we want to use our g equation with the 0. So when we do that, we would have 14 minus 3 times 0. 3 times 0 is first by order of operations, which is 0. 14 minus 0 is 14. In number 3, we have f of negative 5. So when we put negative 5 in, we have negative parenthesis negative 5 squared plus 10. So negative 5 squared is 25, but the negative is still there. So we have negative 25 plus 10, which gets us negative 15. Read the situation below and fill out the three representations: concrete, numeric, and algebraic. So when we look at this, we have the girls basketball team is looking for a place to host the end of the year season banquet. The girls basketball team has found a location they can rent for $500 plus $8 per person's dinner. So when we look at variables here, if we look at our table, it gives us our two variables of number of people and cost. So our independent variable is what happens first. So we have the number of people that decide to come, and then our dependent is the cost. So if we write our dependency statement, we have cost depends on the number of people. So when we go to do this, we said that they can rent it for $500. So it doesn't matter how many people come, they have to pay $500 to rent the space. Then it was $8 per person's dinner. So we would have 8 times 0. So if 0 people came, like if we forgot to invite everybody or tell them where it was at, we still have to pay for the room. So that is going to be $500 for our space that was rented. If we have one person, we have 500 times 8 plus 8 times 1. Remember to multiply first. So we have 8 times 1 plus 500 is $508. Then we have 5 people, so 500 plus 8 times 5 gets us 540. 10 people, 8 times 10 plus 500 is 580. And then 8 times 20 plus 500 is 620. Our algebraic representation, we have two variables. We have people and cost. So remember to identify your variables. So we're going to have people for P and cost for C. Remember, we're trying to find the cost. So cost equals, we have to pay $500 plus $8 per person. Identify the dependency statement as well as the independent and dependent variables. So in number 2, we have the amount of time running versus the number of calories. So our independent variable is going to be the amount of time. This is what happens first. Our dependent variable is going to be the number of calories you burn. So we have the number of calories burned depends on the amount of time running. Number 2, the number of cookies ordered versus the number of people at the party. So if you're trying to plan a party, remember that you want to make sure you have enough food for everybody. So first, you need to figure out the number of people at the party. And then you would do the number of cookies ordered. So our dependency statement, the number of cookies ordered depends on the number of people at the party. Number 4, your family purchases a brand new SUV. The sticker price was 28,000 and the car loses approximately $1,350 in value each year. So, the car value depends on the number of years. Right? The older a car is, the more you own it, the less it's going to be worth because you've been driving it, it's been exposed to the elements, people have been in and out of the car, food, stuff like that. So, your independent variable here is the number of years, and our dependent variable is the car value. So, if I want to have a function rule, I would use V for the car value, and I'm going to use Y for the number of years. So my function rule then would be value equals how much is the car worth is going to be 28,000 minus, because we're losing the value, 1,350 per year. So Y. How many years have passed if the car value is $15,850? So we're going to have 15,500 or 15,850 is equal to 28,000 minus 1,350. Why? So first we can subtract 28,000. So we get negative 12,150 is equal to negative 1,350. So when we divide, we get Y is 9. So you've had the car for 9 years. What would the value be after 15 years? So our value is equal to 28,000 minus 1,350 times 15. So we can first multiply. So we get 28,000 minus 20,250. So when we subtract, we get $7,750. Number 6, Export Fitness has 2 payment plans. You can either become a member by paying a $200 entrance fee and then $3 each time you visit, or you can be a non-member and just pay $13 each visit. So what we have here is that our cost is going to depend on the number of visits. So our independent variable is the visits, and our dependent variable is the cost. So if we have 2 function rules, we have if you're a member and if you're a non-member. So if you're a member, your cost is going to be $200 plus $3 per visit, so 3V. If you're a non-member, there is no cost to join, but you're paying a higher price per visit, so you're paying $13 per visit. How much would each cost to visit 15 times? So if we have the member, our cost is going to be equal to 200 plus 3 times 15. So that cost would be $245. If you are the non-member, your cost is going to be equal to 13 times the number of visits, which is 15. So we have 13 times 15. So the cost is going to be $195. How long would it take for the 2 plans to have the same cost? So because they're going to have the same cost, we're going to set them equal to find the number of visits. So 200 plus 3V is equal to 13V. We can subtract 3V, so 200 equals 10 visits. So V is 10. So we have 10 visits that means they're going to be the same. So before that, one plan is going to be cheaper, and then after 10 visits, the other plan is going to turn and be cheaper. So it just depends on how many visits you want. Our last problem then, the state fair charges $6 for admission plus $2.25 per ride. So your cost is going to depend on the number of rides. Because you have to pay to get into the state fair, but then how much money you spend depends on how many rides you're going to take. So we would have C for cost and R for the number of rides. So cost is equal to $6 to pay to get in plus 2.25 per ride. If Eduardo has $25 to spend, how many rides can he go on? So we're going to set 25 equal to our function rule and solve for the number of rides. So first we're going to subtract 6. 19 equals $2.25 times R. So we can divide by 2.25. And that's going to get us 8.44 rides. So Eduardo only has money to go on 8 rides. We can't round up because if you don't have money, they're not going to let you on the ride. How many rides will it cost? How much will it cost to go on 3 rides? So cost is equal to 6 plus 2.25 times 3. So 2.25 times 3 gets us 6 plus 675. So our total cost is going to be $12.75.